Okay, welcome everybody. There's some people still getting seated, so welcome. Welcome to our session. Let us start by introducing ourselves. I'm Yoav Eilat. I'm a product marketing manager for databases at Google Cloud. And Jana, do you want to introduce yourself?
Yeah, sure. Hi everyone. I'm Jana van Greunen. I'm a director for Cloud SQL at Google Cloud.
Thank you. So what we're going to cover in this session is how you basically get started with using GenAI in your applications and how the database that you use can help you get there faster. So we're going to cover a lot about how today's databases support vectors and other things, other capabilities that you need in order to build. So if you've built a lot of GenAI apps already, then maybe you know some of this information, but we hope this will be helpful as a way to get started. And if you haven't heard anything about GenAI and you've seen nothing about AI at this event, then we'll fix that in this session. Thinking of what it means if you're a small or medium business and you're thinking about all the costs that come with doing a GenAI project, it can feel overwhelming. These are some of the numbers that we've seen, like the amount of money that's been spent by businesses in general on AI in 2023, the amount of investment that has gone into GenAI companies, and the number of developers that are out there and already know how to use these technologies. It can sound overwhelming. Like, I don't know how many of you have $150 billion lying around that you can spend. But the idea is that with all of the new capabilities in Google Cloud and all the models that are out there and all the services that are available, it can be pretty simple and easy and not that expensive to go and get started and build your first app. And we want to show how we do that. If you're curious what other small companies have been doing, we ran a survey in February, not too long ago, and what we found was that, first of all, 92% said that they're already using AI in some capacity. I'm not sure if some of them maybe meant that they're using things that are very easy, like they're using AI in Gmail or Google Docs or things like that. Maybe that's what some people meant by, using AI, and about a quarter of them said that they're actually really using it in an extensive way. So if you haven't started, you're not really far behind, essentially.
Also, should we do a quick survey? Who has actually experimented with GenAI in their applications? So fair number. It's about the 92% seems accurate. Awesome.
Yeah. Okay. And we also asked about some of the use cases that small and medium-sized businesses are using GenAI for. So these are the top 3. What we want to do today is show a demo and actually with an imaginary company of how they would have implemented GenAI. And we'll look at the second item here. So automating customer service and support. We'll show a customer service and sales example, which is very common, right? Mm-hmm. So imagine that almost everybody has a website where customers go and either, get customer service or you're selling something on that website, and this would be an example of how you could use GenAI or database GenAI capabilities in order to make it easier for customers to do business with you. So let's just see how you can go into the leaders group and be one of those 92% that have already started. So what we'll do is we'll use an imaginary company, as we like to do. This one is not called Symbol, like a lot of the demos. We just thought it would be fun to call it Vector Toy. And by the way, why did we do the toy store? How did that idea get?
Well, it's a very easy to understand retail application, and we are obsessed with Ken and Barbie. So hopefully people are enjoying the movie and sort of how popular it is. And I wanted to say, so I did a similarity search, a vector search through my closet. And, this pink sweater was the closest thing that came up to what Barbie would be wearing. So this is my approximation of a Barbie outfit.
Yep. And I refuse to wear what Ken wore in the Barbie movie. So there's no way, especially since this is filmed. So Vector Toy is a company that carries over 100,000 toys. We just made that up. And they want to introduce these technologies to make, they want to introduce a feature that will make it easy for customers to choose what product to buy. And they love Ken and Barbie, so we focused particularly on Ken and Barbie products. There's a lot of them out there. We put them in the database, and we'll see how Vector Toy was able to create that feature. So these are some of the products. What we did is we're using Cloud SQL for Postgres, and we'll talk, of course, much more about the database and what we're doing with it. So it's a Postgres database. These are some of the products. There's many different variations on Barbie. I think you found like, what was it, 170 career Barbies?
Yeah, just different types of careers that Barbie can do.
Yeah. So we copied a few of them into our database. So this gives you some example. And basically the Gen AI, the model is going to, do similarity searches on some of the text, some of the information that you see here. So first things first, whatever you're doing with databases, you want a database that supports Gen AI, but you should also think about the basics that you would want from any database. One of the most important things, as many of you probably already know, is you want to use a managed database service, such as Cloud SQL, because then it takes care of all of the database administrative tasks that nobody really wants to do anymore. Do the backups, do the patching, do replicas in different regions, all of that. It's also cheaper. So we've run some studies that actually show that there's a positive ROI on running a managed service instead of just installing the database service yourself, even if it's in the cloud. And it also makes the database more scalable, more secure, all of those things. So what we really recommend is basing all of that on one of our managed database services. You might be familiar with this slide if you've been to other database sessions or you've seen it, in the past. This is our complete line of database services. You can categorize them by which of them are based on, like open source or publicly available databases like Postgres, MySQL, etc., and which of them have been developed at Google, such as Spanner. And you can also categorize them by relational and non-relational. So there's pretty much a database for every need. Jana, by the way, what's your favorite one on this slide?
So I'll try to be impartial. There's a lot of great products here, but I have to say that I have a slight preference for Cloud SQL. And I think Postgres is our fastest growing database on Cloud SQL, and it's a very vibrant and exciting open source community.
Yeah. So all of our examples today are going to be based on Cloud SQL for Postgres. So what are some of the reasons that you would want to choose Cloud SQL? So you might have seen that especially if you've been in the database spotlight yesterday, we've moved pretty quickly to add Gen AI capabilities to all of the databases that we saw on the slide. Cloud SQL is a particularly easy option to get started with, especially if you want to start small with a smaller budget. It has a very attractive lower entry point in terms of getting started, setting it up, how much it costs. It supports, if you're not familiar, 3 database engines: Postgres, MySQL, and SQL Server. There's an Enterprise Plus edition that came out last year that gives you higher availability, 4 nines of availability, plus some performance acceleration for reads and writes, and longer data retention. So if your application is higher end, it has more users, more traffic, you might want to consider the Enterprise Plus edition. And it has, as we're going to see, built-in capabilities for Gen AI apps. And it also supports Gemini in databases, which just got announced yesterday. So that is a whole series of things that can help you be more productive using Gemini in databases. So it helps you to generate SQL statements. It helps you to monitor your databases and see which of them need attention. All of that using natural language, and that's built right into the product. So it's not so much our focus in this session, but definitely check out Gemini and what it can do in our database products. Okay, so do you want to tell people a little bit about what the pilot is like? Maybe you can take the clicker.
Well, just explain a little bit more about Vector Toy here. So we want to help shoppers kind of find the perfect toy. And we know search is already available, but provide a richer experience and maybe a more fun experience to find toys. We have developed it as a brand new application. It's a little bit of a toy application for us as well. It's not a fully fledged website. And we've based it on Cloud SQL for PostgreSQL. As Yoav mentioned, we downloaded a catalog, a fairly large one of toys, We put that in the database table. And we also did something which we call embedding. So those are already prepared for the GenAI app and that we can just test with various Ken and Barbie configurations. And we'll actually try a live demo, so you'll be able to ask us about these types of questions. And then we'll also have an LLM on top of that, just because everybody is doing it. So quick, maybe introduction here. So Yoav, you already had some ballpark estimate. But if you really was think about, like, if you were to do your custom own, AI model, what do you think that would actually cost?
Well, what I saw in the news is they said that developing a model like Gemini or GPT or any of these models costs at least $100 million to build one.
Yeah, and I mean, who here has $100 million just lying around to try this activity out? I think there's also expertise required, right? Before you had to really have AI developers, you had to deal with a lot of data movement and data preparation. But LLMs take away all of that complexity. And I think the really, let's say, special thing is that, it's just natural language, essentially, right? Everybody can use chat. Sometimes you can't type, but everybody should be able to type questions or even, for example, do translation between natural language and SQL. And so this is, again, instead of understanding Python and really dealing with a model, now you can just chat with it or do what we call prompt engineering to get a much better response out of these LLM models. The other really powerful thing, and I think you can actually see the code for the application, is that using it from the application is just an API call away. So it's like a lot of services that developers are already familiar with. And they just have to wait, essentially, these pre-trained models, select the model that works for them, and they'll get really cool results with just an API call. I think the other thing that we're trying to demonstrate here with databases especially is that it's really in-place GenAI. So there's no need, we developed a new application, but there's actually no need to develop a brand new application. There's no need to take your data from the database, migrate it into a different system, dealing with all the complexities of security, making that new system production ready. I think Yoav mentioned some of the benefits you get from the already managed service. And so this is really just on the existing stack, making it super easy for you to, again, get started and then expand the app. So, again, probably these days people know a lot about LLMs. I think they can do some really, really cool and awesome things. And I wanted to ask Yoav, what is the thing you have used most in this set of activities?
Well, what I would say, the one that got me started, like my first experience with GenAI was the one on the left, sentiment analysis. So this was, I think, close to maybe 5 years ago. And we tried to enter, the sentiment analysis, basically, you enter text and it says if the sentiment is positive or negative, right? If you type in, thank you, this was an amazing product, or this is the worst service I've ever seen, I'm never gonna buy from you again, right? So the thought was, let's use that for customer service applications, because then if people are entering comments or if people are entering reviews and you get, thousands of them every day, that's more than you can read on your own. So, or manually, so using an LLM, using sentiment analysis, you can see like who is not happy, who needs attention. That would be my favorite use case.
Okay. Yeah, I was going to say, I have certainly used it, with the world changing so quickly, a lot of new things coming out. I've used it a lot for summarizing quick learning. And I wanted to do a quick survey here, personally, who has used it just for that purpose? Okay, not as many, but I can really recommend it. There's sort of a bunch of really complicated documents. Summarize it, get started, and I think the awesome thing is you can ask it questions about the summary in the document, and it'll try its best to answer it as well. So moving on from LLMs, the other thing that is very much powering Gen AI or generative AI applications is this concept of a vector, and that is what our databases support. So you might ask, what is a vector really? And I can say it's all about the numbers. So basically, vectors can take real-world concepts. Let's say, people or other phrases. It doesn't have to be a single word. And it just turns it into a sequence of numbers. So, these numbers, I would say, can be long. I think the largest size that's sort of supported is about 1,536. But for illustrative purposes here, we're just going to start off with 2 dimensions. And I think, Yoav, you want to maybe explain a little bit the dimension
Yeah,
diagram?
so when we say 2 dimensions, think of it, I mean, you might remember it from algebra, in high school. So 2 dimensions in the sense that this is a flat slide, right? So we have an x-axis and a y-axis, so that's 2. The real world, if you think about it, is 3-dimensional, as in 3D. So there's a dimension that goes up and down. But if you generalize that concept, it can have any number of dimensions, thousands of dimensions. It's not limited to 3, like the real world. So here for simplification, I think we can use just 2 dimensions, but think of it as vectors with thousands of numbers in them, at least, if not more.
Yeah. The boy example here is just a made-up example. I didn't really get the embedding for boy. But you can imagine if you just plotted the first 2 coordinates in space, it would be somewhere on this 2D image. And now what gets really interesting is if you add additional words or additional concepts. So for example, you might be adding girl and then Ken and Barbie. And so what you can see with the way embeddings work is it'll cluster like boy and girl closer together because they're both people. And the toys are, a little bit further away, but also clustered closer to each other. And then, Ken might be slightly closer to boy and Barbie might be slightly closer to girl. And that really enables sort of the database to go find these vectors that are closer to each other in the multi-dimensional space. And basically that's how you get similarity search, which is a really powerful concept. And so what I would say is databases are good at storing numbers. They're good at crunching numbers. They're good at creating indices over these numbers. And so within Postgres, we support, I think the initial one that came out is IVF flat. It's much simpler, but it isn't quite as performant when you're doing queries over large data sets. And now there's also one called HNSW. And so both of these are available to kind of play around with, to tune, and to find these similar vectors.
And just to clarify, so Ken and Barbie are close to each other because the model essentially knows who Ken and Barbie are, right? And we'll see that later in the demo. It's amazing how much Gemini knows about Ken and Barbie. It's pretty shocking.
Yeah, well, it may not have yet ingested the movie, but
we'll see. We'll find out.
So here on the screen is just a very simple kind of diagram on how you might construct an app and how the data is flowing. So your app is here in the green box. And then the user, there'll be some text input where the user will find, type some question like, hey, find me the closest other toy to weird Barbie, for example. We do use an embedding model. So that's the thing that turns the text into the vector numbers. Then there's a call to the database to go find similar vectors. In a more complex app, which we'll show in a second, you can have additional components. But if you, for example, just want to say, return the vector, and then there's a maybe catalog description, that will just get returned from the database and you can show it to the user. And maybe similarly with other types, it doesn't have to be just product catalog. It could be other, maybe support tickets or other types of things. So in the more complex example, I was going to say, who has ever heard of, maybe I'll start with hallucinations. Okay. And then there's a term, it sounds very short when you say it, RAG, but it actually stands for Retrieval Augmented Generation. And I was hoping, Yoav, you could maybe help us out a little with explaining it.
Yeah. So basically that means, RAG means that we go to our own database in order to ground the results. So meaning that the data that is in your database actually enhances what the model already knows and gives an answer that's hopefully not a hallucinating answer. So think about what the model is trained with and the data that you have in your database, right? So if you ask the model, I don't know, what's the capital of France, then it already knows that because it was trained on that when Google trained the Gemini model. But if you ask how many, Barbie shoes do we have in stock, Gemini was never trained on that, right? That comes from your database and it can change every second. So we have to find some way of grounding, if you ask that question, going to your database and using that data in order to ground the result that Gemini comes back with. So that's basically the reason why we need to do that.
Yeah, and again, that's a very powerful way to augment a model, to customize it, right, for your business, without actually even doing fine-tuned training or full training. So in this more complicated example, right, the app is still in the green box down here. But you might use an application framework to help with the orchestration because there'll be some back and forth between, sort of what the application is seeing, the LLM that's sort of generating some text or maybe even evaluating some generated text, as well as the database, where we're actually getting the groundings from, potentially getting some of these similarity searches out as well. And so a really popular framework a lot of people are using these days is called LangChain. We are also partners with them, and I believe this application is probably a little bit simple, but a lot of our other example applications are integrated with LangChain, as well as our databases are integrated with LangChain. This gives you kind of an easy JSON interface instead of SQL, but obviously you can also use SQL for a database. That part always works. So again, in this example, we can actually try this one on the app. Instead of just finding toys, you might want to say, hey, write me a script for a Barbie movie with some toys in it. This will go through a series of interactions, right, where you might do first a call to the database to figure out what toys there are. Then you might put those in the prompt, send it to the LLM. The LLM, comes back with some made-up story or script in this case, and maybe doing, similarity searches to find out within a scene which toys are relevant to each other. And then in the end, that all gets basically generated as a nice text and gets sent back to your application. I mean, from the application's point of view, it's still a set of API calls. And in this case, the database and the LLM, which in our case is Gemini, will do all the heavy lifting. So I think just in a quick summary, we went through a lot of things here. But the database is really to store the vectors. So that's, your product data in vectorized form, as well as during the time the application is running to ground the answers and to customize them for your business application use case. So the other thing that we've used here, we've used Google tools to make this application happen. We run the application itself on GKE as a Kubernetes application. As we've already said, it's a Postgres for Cloud SQL database that's storing all the data. And then we call out to Vertex AI for the models I think we're using Gemini Pro. We can certainly try the latest one as well. And just a quick thing, it is actually all on GitHub. So if you do have access to this, you can just go to this link and basically see all the code behind it. If not, we can send that to you. Cool. So maybe if you want to do a quick intro for the demo, Yoav.
Sure. The first thing I want to mention on this slide, actually, we should have said it earlier, is that all of these pictures are generated by Gemini. So for this one, I went and said, show me a picture of Barbie's house or something like that, and this is what it came up with. So it was pretty good. So it's all Gemini generated. So this is a toy agent which basically helps a customer go and shop for Ken and Barbie toys, right? And then what we do is we run a semantic search, meaning we do a search on what we typed in, and we try to see which of the products in our database, which of the Ken and Barbie products are the best fit for what the user said. And it's built on Cloud SQL for Postgres. So everything is based on storing the vectors in our Postgres database and also using the data in our Postgres database, like the toy inventory, like the toys that we have for sale, in order to ground the result and give us back an answer. And we want to try it live. We also want to get your ideas. So in a few minutes, we just want people, if you want to suggest a prompt to us, and we can just type it in and let's see what happens. It's completely live.
Okay, let's get started with the demo here. Okay, so we have built here a simple UI that is running on, as I mentioned, Kubernetes. I would say I'm not a UI engineer, so excuse the the slight, I guess, display. I will get started with one or two prompts just to give people an idea, and then we'll get some ideas from the audience. So let's say, for example, Barbie. So let's say you're shopping for your kid, and your kid already has a Barbie, but now they want additional toys for Barbie to go do some fun activities. So let's just say we say Barbie wants to go to the outdoors. How can she? Sorry, also. She get there. And then if you hit enter over here, it will say that there's actually a Barbie camper playset. And this camper playset, I would say, is a little bit amazing because it doubles as a truck, boat, and house, like the house that Yoav drew over there. And it has also lots of other kind of fun attributes. And so, as you can see, this is not quite like a traditional search. It is a little bit broader. For example, if I said Barbie wants to go about town, you just something, sorry, then it will say, so, it's no longer saying the camper because that would be a little bit awkward to drive around a town with small streets. Now it is a pink and shiny two-seater convertible, maybe like the one that you saw in the movie. Okay, so after this, we'd like to take, some ideas from the audience. And like I said, you could even explore a little bit beyond just the straightforward find me this toy types of questions.
And can you explain again in the meantime while we're getting set up, so how did this application, again, how did it know when we said outdoors, it suggested camping? How does it know that outdoor is related to camping?
Yeah, that's a great question. So this is, again, going back to our concept of vectors. And so, when you put the data in the database, you have to kind of go from the catalog description into a series of numbers. And this series of numbers exactly places different things sort of in the multi-dimensional space. And so when camper gets translated, maybe there's one vector that's related, or one number that's related to outdoors. And then when I type in my prompt, that also gets transformed into vectors. And then these two concepts are close to each other. And so it can find a match, basically. I think the other thing, and this launched, I think maybe in preview, we also, right now, you have to separately call Gemini. We also do have a tighter integration with the database so that, when you store your data in the table, we can automatically retrieve the vectors and store them, basically in the same Postgres database that you already have.
Okay, thank you. So we have the microphones. Does anybody want to suggest a prompt? And let's type it in and see what happens.
I think if people are shy, I can try the write me a script. Oh, is there one?
Thank you.
So my daughter wants to make a Barbie stop motion movie. What can she use to make this?
Yeah, can you repeat again the first sentence?
So my daughter wants to make a Barbie stop motion movie.
A stop motion. So my daughter wants to make a stop motion movie.
A Barbie stop motion movie.
A Barbie stop motion movie.
What can she use for it?
What can she use for it?
Submersion or subversion?
Stop motion.
Stop
like
motion. Oh, okay,
movie.
okay. Stop motion movie. Let's see if this comes back with a toy. Okay, so I think unfortunately it is assuming that your daughter is searching for characters within this movie. And so what the application suggested was actually a toy to use in the movie.
The Barbie Dreamtopia doll is a suitable toy for your daughter's stop motion movie project. It is possible. This is a posable ballerina doll with tied up features and a beautiful sparkly pink tutu. Okay. Hope that's helpful for the movie.
I can scroll down. So it just gives you kind of the price and a little bit more. Yeah?
Correct. Here's one of my favorites. I hope it works. Let's try one of mine. Mm-hmm. What would you suggest for a child who saw the Barbie movie?
Okay. God. See, it's really live because I can't type. Okay, let's see what it comes up with. So it is referring to the car here that's in the movie.
Yeah, it is a die-cast car that resembles Barbie's convertible in the movie. In other words, Gemini knows what was in the movie. Like, we were shocked when we ran it. Like, it knows the plot of the movie and what car she had and what they were wearing. And then it just matches it with one of the toys that we have in our database. So it's pretty amazing what these models know at this point. Does anyone want to suggest another prompt?
More? Sorry, I think for the microphone runner, there's one
Just
on the
raise
right.
it, yeah.
Yeah.
Hi. Does it work if the sentence has grammar mistakes or spelling mistakes?
I think for the most part not. Would you like me to try a spelling mistake or maybe phrase something grammatically incorrectly?
Yeah, that would be great. I cannot really. You can try anything like which has grammar mistakes or spelling mistakes.
Yoav, do you want to?
I think it's a little...
Okay, how about this? Travel, Barbie wants to go. Let's see if, okay, well, okay, how about maybe a slightly different one? Maybe I'll just put some thing in there and see. Okay.
Yeah, I think it's recovered pretty well.
Yeah, so it's suggesting that the house, because as according to this, the Barbie house comes with 6 pets already pre-populated and 2 homes for those pets within the Barbie house. There's one more. Yes, we can. I don't know if there is one in here. Barbie car. Okay, this one is above, so it's not really, okay. Any car. I don't actually know if we have a car below $20. The Barbies themselves tend to be cheaper, so they're about $14 for anybody who's in the market for a Barbie, and some of the cars are a little bit more.
It's a combination, right?
Yeah. Yeah. Oh, sorry. Let me maybe explain. The pictures over here are not actually related to the toys in the database. Apologies for that. This is our UI design team and our database team didn't quite coordinate well enough on this presentation, as might happen in real world companies too. But as a maybe quick answer to your question, you definitely can filter by other columns in essentially your table. And so we do filter already, but I think there just aren't cars that are cheaper than that. So it still tries to return something to the customer.
Awesome.
So we were actually thinking about that. You can do either. Because once you essentially have the vector, right, it's easy just to have further SQL queries and filter things or exclude them. But in this case, I mean, we initially didn't have the price filter, and then we were thinking of just adding it to the description as basically part of it.
I'm just wondering whether it would handle the gender correctly. Could you please try to recommend something for my son, not from my daughter?
Something from where?
So recommend for your son or daughter separately?
Oh.
Yeah.
Okay.
Okay. I'll say. Son. Let's try that. It's a car, so maybe a little bit. But how about my son? Likes sport. Okay, let's try. Well, this way. Okay. And let's see what it comes back with. So at this point, it is the Ken soccer doll. I think kids like to play with toys of all genders, but the LLM did actually kind of make the switch between returning a Barbie option versus a Ken option.
Thank you.
As we talked before about many Barbie configurations, there are also many Ken configurations online if you do a search.
Okay, that's awesome.
So I have a real challenging question for it. Can it do it in other languages? If you ask it in a different language, will it respond with a description in that language, or will it understand that language?
So that is a very challenging question, yes. I believe that the model will understand the language, and because it's translating it into a vector, that part should actually work. In terms of the response, that will still be in essentially English because it does use the description column to pull some of this information out. And I don't think it will automatically translate. We could probably embed in the prompt, please translate your answer into whichever language. And then I've actually seen LLMs do that, but the database will still be, we put English descriptions in.
I mean, that makes sense. I mean, do you want to try it? Just see what it produces.
Sure.
Just in a different language, see what it...
Yoav, do you want to try another language?
Not right now. Well, we can maybe follow up and try it together.
Yeah, sorry, we're not experts in other languages, unfortunately.
Yeah. Okay. Well, hope this was helpful for getting you some examples of how we do vector search and how we use embeddings to find the perfect answer here.
Yeah. Shall we go back to the...
Yeah, I think we can continue from here. So a few things to wrap up and maybe some things that you can use to get started if you want to do something like this with one of your applications. So first of all, as we said, we have vector support. We moved pretty quickly to add it to all of our databases. So every one of the databases of the managed databases from Google is in some stage of getting vector support, whether it's generally available or at least in preview, right? And Cloud SQL for Postgres is already GA, right?
Yeah, it's generally available. Yeah.
Right. A few more words about LangChain. So essentially, LangChain, as we mentioned, it's a very hot tool to help you standardize the way that you work with large language models and embed them into your applications. Actually, the CEO of LangChain was on stage yesterday in our databases spotlight. In case you were there, you might have seen that. So basically what it does is it helps basically standardize all of the common actions that you take as you're developing a GenAI application, like a chatbot or whatever else you're building. So in a chatbot, for example, you're going back and forth with the user several times, and you want the model to remember the conversation so that it can keep up the conversation and it'll know what you said so that you don't have to say it again, right? You want the entire history of that chat to be an input every time the model returns an answer. So LangChain can help you automate that part of it. It can help you read and write from the database, store the history of the chat, do all of those things that basically anybody who is using a large language model would probably want to do. So that way, applications are easier to maintain, and you can see you can see the way they were built, and you can switch between models. You can do all these things in a much more standardized way.
I just wanted to add maybe one thing, and actually if we can go back to the demo. So kind of as Yoav mentioned, like LangChain is a tool that helps developers basically do it at the application layer. And for some of the large models, there are also tools where you can see what actually goes into the prompt. And that's usually a little bit different from what the user initially typed in, just because there is this back and forth and potential information retrieval. But I wanted to very quickly, if we can switch to my screen.
Switch the monitor again.
So what I wanted to talk about quickly is some of the built-in tools we have in the database side to help you. So if you're starting off just writing your first application and maybe it's going slow or there's some issue, we essentially for Cloud SQL have a pre-generated what we call query insights. And so this is the database that the toys inventory app is actually running on. And you can see it's not super busy right now because we're not running too many queries. Generally. But if you're going to query insights, you see these little spikes, and this is where we were typing the actual question. So the database had to work a little bit harder because it's calculating, all of those. It looks at the index, but then it still has to calculate a lot of distance numbers to find the closest vectors. You can, look here, for example, this is the vector command that got run. Here, it'll give you the SQL that's generated, and then you can also look kind of across all of the different actual SQL statements that it used to generate this result. And so if something isn't being used properly, you can add that. Here we see, for example, it's using an index scan. For some of these vector queries, it can actually skip the index if you're not configuring it. So you might actually see performance issues that you can quickly debug in this view, and it's very helpful as part of our offering. And over time, this is another area we're going to make sort of better and better as generative AI apps start becoming more and more popular.
Thank you. Okay, we can go back to the slides. Let's talk very quickly about how you can get started. What we would recommend is, first of all, continue to go to sessions like this one at Next. Learn about what GenAI can do and what GenAI can do with databases that you might already be using or that you can adopt. Look at some of the reports that we've published about what people are doing with GenAI. There's a link here, a shortened link that you can use. Run the tutorial or the GitHub example that you mentioned earlier. It's a 30-minute example, and basically after you see how to do that, just go and basically just hack it and make it into your application, right?
Yeah.
Then I would say plan for which application to start with. So you don't have to convert, add GenAI to every single application that you have in your business. Start by thinking of one, maybe something around customer service, my favorite, maybe something around an internal application that's being used for employees are looking for information for something. Search is usually a really good use case. So start with one and then go and build it. And from there, hopefully it'll seem easy when you do the next ones. So that's about it from us. You've seen the slide before, so you can go and see some of the material from Next that you can use to get started more quickly. And of course, go to other sessions that are related to this one. So we made a list of a few sessions that are all in the database, sort of the database space that talk about how to use GenAI in your databases. And there's a demo in the showcase on the show floor, both for building a GenAI app and for using Gemini in databases and seeing like query insights and some of the things we saw earlier today. All right, well, thanks everyone. We've had a great time and hope you did too.